organise un congrès de 200 personnes à l'Expression Estibiana. Donc j'avais prévu Vitaly de rester jusqu'à 9h pour accueillir les gens.
Yes, if you leave me your presentation, I will take care of this. Thank you. Peter van den Nabele and Laurent Sifogel. This meeting is the first in a series that will be a sort of satellite conference to the ECTO meetings, and I will explain what is ECTO in a minute. The title of the meeting will be the immune response against dying tumor cells, and I just give you 2 minutes of introduction of what is the problem that we will discuss during this meeting. Usually, when you look at a textbook, and I can refer to any textbook that is actually in press, you find the equation that programmed cell death would occur through apoptosis, which occurs through caspase activation, and is managed in a way that the cells are phagocytosed by the neighbors and leave no traces of corpses, no inflammation, and occur in a non-immunogenic fashion. And this equation is, of course, completely wrong in each of its details, meaning that programmed cell death can occur through apoptosis and other death modalities. Apoptosis is usually accompanied by caspase activation, but not always. And caspase activation is not required for cell death to occur. And apoptosis can be immunogenic in other cell death modalities as well. So we have to be careful about collection of data, the interpretation, and the way how we do science, and we use words. And we study for free. And there are also commercial sponsors for minor items, AstraZeneca and in vitro genomics. So I would like to thank you again for coming here. And I think that we can pass without further delay to the first talk this morning. Anna Carolina Paluca from Dallas, who will talk about dendritic cells of therapeutic drug science in cancer.
It is a great pleasure to be here. I just want to say that I cannot talk much about the type of the cell death, as I really don't know much about it. But what I would like to talk about is dendritic cells and how can we use killed tumor cells to deliver antigen to dendritic cells for the purpose of vaccination in cancer, and perhaps show you some data, including some very recent data that have surprised us and maybe have very simple explanation, but that may open a discussion. So the goal of the therapeutic vaccination in cancer is, of course, to elicit these CTLs that would be able to recognize cancer cell and eliminate it, and the way it will eliminate it will be through the death. And I don't know how much do we know actually about the consequences of this type of death, and I will pose this question to you. Nevertheless, our major goal is, of course, to induce, even regardless of the type of the dendritic cell. What we decided to do there was to actually take advantage of the clinical observations from old, if you will, for the lack of the better word, oncologists, who actually found that hyperthermia, and it is still used until today in some of the superficial tumors, that hyperthermia may be therapeutic in cancer. And of course you are all familiar with that because the heat induces, and there is a lot of work done and has been demonstrated that that may be due to the heat shock proteins that may be chaperoning peptides and permitting antigen presentation. So what we decided to do was to hit the tumor cells before they will be killed. And in this system, the way we are killing the melanoma cells is a combination of TNF and serum starvation. And unfortunately, and I say it on purpose, unfortunately, Because of the regulations of the FDA, we have to gamma irradiate the tumor cells, and I think that at least in our hands, I believe that that has detrimental effect to the capacity of this, to the efficacy of the cross-priming. Nevertheless, that's the way we need to do it. And so
yes, Monica, very nice talk, very interesting talk. Maybe also for the future of the discussion later. My question is for the last part of your talk, when you use apoptotic bodies for EIC, of course, because these 2 last days we discussed about the probable effect of poly-EIC.
Clinical situation when you're confronted with a patient that has a tumor, you subject it to radiotherapy or chemotherapy, usually in a systemic fashion, and then you get hopefully a partial response. But the failure to eradicate all the tumor cells leads to relapse and finally to the death of the patient. And it's generally thought that chemotherapy induces apoptosis, which would be a non-immunogenic cell death modality. So the therapeutic goal that we pursue is to kill tumor cells by a chemotherapy in a way that the cell death would be immunogenic, elicit an immune response that would eradicate remaining tumor cells and tumor stem cells and allow for a complete cure of the patient. Now, before I come into this, I would like to introduce some basic notions on cell death. So remember that cell death is still defined in different fashions. An apoptosis is a cell death modality in which the nucleus undergoes characteristic changes. And we came into the business of immunogenic cell death by serendipity because many years ago we discovered that mitochondrial membrane permeabilization was a decisive step in the cell death process occurring through apoptosis and actually delimiting the frontier between death and life. And that mitochondrial membrane permeabilization led to the translocation of a protein that we call AIF, or apoptosis-inducing factor, from mitochondria to the nucleus, which in a caspase independent fashion can induce chromatin condensation, which is one of the hallmarks of apoptosis. And we also found that in some tumors, particularly non-small cell lung carcinomas, HER protein 70 was overexpressed, which inhibited the translocation of AIF from mitochondria to the nucleus due to a direct physical interaction. And when mapping this interaction at the crystallographic level and by mutational analysis, we could determine a domain within the AIF protein that interacts with HSP70 that allowed us to construct a peptide that we called ADD70 for AIF-derived decoy of HSP70 in tumors. So I show you the actually growth curves. So we establish tumors, here in this example, colon carcinoma in immunocompetent rats, or a melanoma in immunocompetent mice. And when the tumor is established, we introduce a peptide plus minus cisplatin as a chemotherapy, and you will see that the combination of ADT70 plus cisplatin allows for complete cure, which is of course a very satisfying experiment. And the surprise was that this kind of result was only obtained in immunocompetent mice and never in nude rats or nude mice, where the combination therapy led to only a minor delay in the growth curve.
Thank you, Meredith, and thank you to Guido and Laurence for organizing this exciting workshop. So, while we've already heard a little bit about cross-presentation and cell death, I do want to give a very short introduction to the questions that my laboratory has been working on. And what I'm going to tell you about is actually that cell death, while potentially important for generating plasmapeptide complexes for purposes of inducing an immune response, you just heard from Guido, It's also limiting the possibility of generating efficient cross-priming. And it's doing that by limiting the antigen. And I will tell you sort of a recent story from the laboratory, work that has been done by a very talented physician in the laboratory, Helen Saklani, and a medical fellow in the laboratory, Martin Wool. So we've been curious for now probably 12 years about how tissue-restricted antigen is handled by the immune system for the induction of either a priming or a tolerogenic response with respect to the CD8-positive T-cell responses. And by tissue-restricted antigen, I mean proteins that are exclusively present within peripheral tissue, be it self, tumor, viral infected, or neo-self-antigen situations of transplantation. And I think that it's already been well introduced that dendritic cells are very efficient at capturing antigen, which they can do in their immature state. And upon maturation, traffic that antigen to the draining lymph node, where you get presentation and engagement of CD8 positive.
An important role for apoptotic cells as a mechanism of delivery.